Hi. At some point, everyone has to learn their ABCs. But not only do we have to know it, we have to remember it forever. But it's similar with computers. Computers have to learn them too. But they have an entirely different system for doing it. They store memory, and memory for a computer is measured in bytes. There are different types and different measures of what the byte can do. There are megabytes, terabytes, kilobytes, and nanobytes, and a whole bunch of different measurings for how much a computer can store in their memory banks. But just how much memory does it take for our computers to remember a series of letters? So what I'm going to do is I'm going to talk a little bit about my method that I made for this project, and what my findings were, and then a little bit from what I drew from my findings. Okay, so we live in an age where there's a vast amount of memory. We have terabyte external hard drives that can store hundreds of millions of songs, to thousands of videos, to hundreds of books, and everything. Sometimes that is just makes us lazy, because it used to always be that computers would only go up to like a gigabyte or a megabyte or a couple megabytes. So have we become lazy, or have we just like forgotten what it was like to code with very little to work with? Well, with my experiment, I wanted to see just how much it took to write a string of letters into a Word document. So my experiment has a little bit to do with, well, a big part of it is how to actually do it. So for my method, I continued with a certain setup. What my setup was: my laptop, a text document, usually Notepad, or if you have a Mac, you use a text edit file, and you open that up. You place whatever it is in the document and save it. So for a couple experiments, I would place like A or ABC or all 26 characters of the alphabet into the document and save it. Then I would save it to the desktop and rename it what experiment number it was. Then I would take that file and move it to an online database where I could effectively evaluate just how many bytes of information was there, or how many bytes were being used to store the information. And I would cross-reference it with what my laptop would say that the file used. And if they were both the same, then I would record the number of bytes for that file. And I'd do this over and over, and I'd change different variables for what I plugged into the text document. Like sometimes I'd play with like spaces in between the letters, or I'd capitalize some letters, or I would do like different strings of letters, and then save them into the file. So let's talk a little bit about my findings. So I have all my findings here. It's in a chart about, I don't know, this big, this one, on my PowerPoint. And it just basically goes through each and every one of my experiments and numbers them. And then in this, like, here's this row, and that's the number. And this row would be the actual type of file it is. And then this would be the number of bytes that were stored in that file. And then all the way over here would be what variables I included, or what letters I included in that text document. Alright, so let's figure out what I can conclude by looking at this data that I've set up. So I pointed out a couple things, but let's talk about a couple of them. Capitalization, I noticed by looking at the data, doesn't really matter. Like for experiments 5, 7, and 8, and the reality is, if you type something up and you capitalize something, it doesn't really need to be. It doesn't affect how many bytes the file as a whole uses. It doesn't matter. Another point is another thing that I can conclude from the data is that spaces really matter. Like if you have a space after a letter that you type in, and then you have a B, like okay, A space B, then what I found is the space has its own byte of information that the file that has to be stored. Otherwise, the computer won't remember that there's a space there. So that's why spaces are really important. What I also was able to conclude by looking at my data was that each individual character was assigned its own byte. Now this only worked for text-edit documents because they really didn't have any font or size of text or really anything to change the value of or size of the file or the size of the information that needed to be stored. Like for instance, if you save a Microsoft Word document without anything in it, it's already up to like 12,462 bytes of information. That's a lot of information just for having nothing in it. So for future reference or future implications of this project, you could really go into like Microsoft Word document and like show how much you could actually type with that program using only like a 38 megabyte hard drive, like you would use way back in the day, and just see how much you could actually type up before it wouldn't let you type up anymore. And that would give you some idea of how primitive computers used to be. Does anybody have any questions? Alright. Now this is the part where I would answer them, and then I would go over what the strengths and weaknesses of my method would be. Like, did I find anything that I could have done better? Like, could I use an example, or could I do like one of the experiments really quick in front of the audience to make it more clear how I did the experiment? But that's about it. Okay, thank you.